So let us try to understand how to locate the instantaneous center of rotation for single slider crank mechanism. As shown over here, this is our fixed link, this is the crank, is the second link, then 3 is the connecting rod and 4 is the piston. Now we'll use the circle diagram method to locate the instantaneous center of rotation. So first we'll write down the link numbers over here. So 1, 2, 3, 4. Then corresponding ICRs. So you have to first write down the ICRs in this particular fashion. So this 1, 2. You have to start from 1. So this is 1, 2. Then 1, 3. Then 1 and 4. Then you have to go for 2, 3. And then 2, 4. And finally 3, 4. So there are 6 ICRs because as there are 4 links are there, so number of links are 4. So the formula for the number of ICRs in particular mechanism is n into n minus 1 upon 2, where small n is the number of links and capital N is the number of ICRs. So it is 4 into 4 minus 1 upon 2, that is 6. So there are 6 ICRs, so as we have indicated over here. So again, try to understand. Start from 1. So 1, 2, then 1, 3, 1, 4, then 2, 3, 2, 4, and then 3, 4. Now, out of this 1 and 2, they are joined over here. So this is known as instantaneous center of 1 with respect to 2. And it is known as the fixed ICR because out of this 1 and 2, 1 is the fixed link. Then 2 and 3, they are pin jointed over here. So this is known as the permanent ICR, as neither of these 2 or second or third link, neither is fixed, so it is a permanent ICR. Similarly, 3 and 4, that is the third link is the connecting rod, 4 is the piston, they are connected with the help of the gudgeon pin. So as they are pin jointed over here, this is the permanent ICR 3, 4 because neither 3 is fixed nor 4 is fixed. But the most important ICR is 1, 4, that is the slider 4 is sliding. This particular slider is sliding in the horizontal direction with respect to fixed link, that is 1. So the sliding motion can be described as the rotation with the infinite radius. So you can say that this particular ICR is perpendicular to the path of sliding, so as it is indicated by this blue line and going towards infinity. So the property, another important property of this ICR is that it can be shifted to any other ICR. So if you want to draw this particular ICR through 2, 3, then just draw a line parallel to this particular 1, 4 passing to 2, 3. Similarly, if you want to draw this particular ICR passing through 1, 2, then you have to draw a line parallel to this line and again passing through 1, 2, like that. So we can shift this particular ICR to any other ICR by drawing a parallel line to this particular line, which is nothing but perpendicular to the path of sliding of that particular slider. Now, out of these 6 ICRs, these are the ICRs as we have indicated over here. So 1, 2, then this 2, 3, then this 3, 4, and 1, 4. So by observation, we can locate these particular ICRs. And this 1, 2, we have joined over here by a solid line. This 2, 3, we have joined by solid line. Then 3, 4, and 1, 4. So the ICRs which are known to us, they are joined over here in the circle diagram by solid lines. And now we have to start locating this particular ICR. Suppose we want to locate 1, 3. Then join this by a dotted line. It will form 2 triangles. So this is one triangle, 1, 2, 3, and this is the another triangle, that is 1, 4, 3. So the combination is, suppose we consider this triangle, leave this 1, 3 as it is. Take into consideration the other 2 ICRs, that is 1, 2, and 2, 3, and write down that combination over here. Similarly, consider the another triangle. So this is 1, 4, and 3, 4, and write down that combination over here. Now we'll see how to use this particular combination to locate the ICR 1, 3. Now we have to join this particular 2 ICRs. So 1, 2, and 2, 3. We have to join it. They are already joined, as you can see over here. 1, 2, and 2, 3. Just extend them, join and then extend them. So we have extended it in this particular fashion. Then 1, 4, 3, 4. Now you have to be very careful about this 1, 4 ICR, which is going towards infinity. Now this particular ICR is in combination with 3, 4. So it must pass through this 3, 4. So it is already passing through this 3, 4. Just extend it. Wherever these two particular lines they intersect each other, that is our ICR 13. So in this way we have located this particular ICR. Now the last ICR that we have to locate is 2,4. So again join these 2,4 by dotted line. So again you will form these two triangles. So this is the first triangle, this is the another triangle, and the combination is, suppose we consider this particular first triangle, leave this 2,4 as it is, don't consider this 2,4, see the another combination 1,4 1,2 that we have written over here, and then for this particular triangle it is 2,3 3,4, so that also we have considered over here. So 1,2 1,4. So again now you can see this 1,4 is the ICR of the infinity, it must pass through this 1,2 ICR 1,2. So ICR 1,2 is over here. Through this ICR draw a line parallel to this particular ICR which is going towards infinity. So you can see we have shown it over here by the faint blue line. So this is the ICR 1,4 which is passing through 1,2. So this is the combination under consideration. The next one is you have to join these two particular ICRs 2,3 and 3,4. So this is 2,3 and this is 3,4. They are already joined, just extend them. So wherever these two intersect, that is this particular line and the previously drawn line, then that particular ICR is I24. So in this way we can locate the ICRs for single stagger time.